Unit 10, comparing two populations or groups. The goal of two-sample problems. So basically you're trying to compare two responses to two different treatments or compare characteristics of two different populations. The responses that you're going to get are going to be independent from each other. An example of when you would use a two-sample problem is if you were comparing grades of fraternity members during the fall semester and the spring semester. Two-sample test for means. So with the name step, you would say two-sample Z or t-test for means, and you would use Z if you knew the population standard deviation and T if you did not know it. And for the state step, you would define mu1 and mu2. Of course, you have to include context. And then H naught would be mu1 is equal to mu2, and HA would be mu1 is not equal to mu2, or mu1 is greater than mu2, or mu1 is less than mu2. Conditions for comparing two means, and this would be in your plan step. So the first condition is random. Both of the samples have to be random and from two distinct populations or from two different treatments. And your second condition is normal, which is either given in the problem or you have to use CLT for both of the samples, and that states that both samples have to be 30 or greater, which means that the sampling distribution will be approximately normal. Or you can also graph each sample separately to see if they're approximately normal. And the third condition is independence. Both populations have to be at least 10 times the sample size. So this is the do step for a test for two means. And if you have the population standard deviation, you would use a Z statistic using this equation, and then a T statistic if you are not given the population standard deviation, and you are required to state the degrees of freedom for t-tests. How to find DF. So you can use the formula which is shown, but it's really long. So you can use the conservative DF, which basically you find N1 minus 1 and N2 minus 1, and the minimum number of those two is your conservative DF. And then the third option is the calculator, which is the fastest, and the steps are shown. So next is the do step, and the data is given in the table. So first you find T using the equation, which you can also find on your formula sheet. Then you find the probability of T being less than the value that you calculated. In this case, it's negative 4.84. And then you use TCDF. You have to label lower, upper, and DF. And you find DF on your calculator or using the equation that we showed before. And then finally, the probability is about 0. And then with the drawing, you can see that we shaded below negative 4.84, which is the probability that we were finding. Okay. Next is the conclude step. So if the p-value that you found before is less than the alpha value, then you would reject H naught because there is sufficient evidence of HA. And if the probability value is greater than the alpha value, then you fail to reject H naught because there is not sufficient evidence of HA. And remember to include context. So next is the two-sample interval for means. That is the name step as shown. And the state step is the same as before, so you would define mu1 and mu2. The plan step is also the same, so you would check the same conditions. And the do step is estimate plus or minus the margin of error. And once you find your interval, you would conclude, and remember to use context. So you would say something like, we are 95% confident that the true mean on average is between 1.01 and 11.99 milligrams of mercury higher than the mean of blah blah blah. And because the two numbers in the interval are positive numbers, that is why you can say in the conclude step that the mean is going to be higher. Okay, so here are some cautions and limitations. The first one is that after you get results of a hypothesis test, this does not mean that you can right away prove H naught. Based on your results from the test, this shouldn't make you convinced that there is no difference between two population means, or that there isn't a difference between two population means. In this case, we would just fail to reject H naught. So the next one is, if all information about a population is given, there is no need to carry out a test. So the next one is, statistical significance is not the same as practical significance. So after you run a test, the results that you get are not gonna give you the full picture, so it's a good idea to run a confidence interval so you get practical significance. It is a common mistake to use paired data as two independent samples, so it's important to know how the data was collected so you do not make that mistake. Paired t-tests. So if you are given before and after data, find the differences of the data first and then run a test using those differences, if that's what it asks for. And in the state step, it is important to state the direction of subtracting, and then you would follow the same steps as we showed before to perform a test. Okay, so confidence intervals for two proportions. It is estimate plus or minus the margin of error, and the conditions that you have to check, random and independent, are the same as before, and normal, you have new stuff to check, which is shown, and then at the bottom is the estimate plus or minus the margin of error. Significance test for two proportions. So H naught would state that there is no difference between the two populations, so P1 would equal P2. And in this case, you would use PC, which is a combined sample portion. It's basically the counts of all the successes in a sample over all the individuals in both samples. And it is important to remember that this is only used for two sample t-tests for proportions. Okay, so conditions for comparing two proportions. Random and independent are the same as before, and normal, you would check all of those, but you would use PC this time. And shown below is how you would get the Z statistic. Oh, and in the normal area, all of them have to be greater than or equal to 10.